Got it. Boom. We out here. Yeah, shout outs to y'all for joining the class. I appreciate y'all. And I want to, start us off with a pretty interesting kind of conversation. And please do not mind the date of this presentation. It's a presentation that I've made a while ago, but at the same time, I think it's real relevant to the conversation that we're going to be having this whole next few weeks. So today I want to talk about what is the web in web development. You know what I'm saying? Like we gotta break some things down before we start building some things up. And so essentially, like when you start out coding and you're in especially in the full stack space, you're gonna hear everybody talk about web development, web development, web development. And honestly, I feel like it's very important to get a good understanding of what that means when you're talking about the web part of web development, so that you understand just how broad and how important the role that you'd be stepping into really is. So just quick pulse check. If you feel like you kind of got a good understanding of what the web means, just drop a thumb up. You could use a thumb up react to drop it in the chat. But just kind of want to see if somebody was like to tell you like the web and you're like, oh, I know what the web is. Like, okay, cool. Got it. Yeah. So it's good to see some folks got it. And then for some, it's worth kind of asking the question. Dope. So we're going to talk a little bit about that today. Let me see. How do I go from slide to slide? All right, bet. So in order to talk about that, we're going to cover a couple things. First is really kind of getting a background of this information and understanding like a really big point, which is that the web is not the same as the internet. That feels like the hottest bar of like all time. That feels like a Kendrick level bar, but for real, it really is the case. The web is not the internet. And that's like the one biggest thing that if you take away from this little presentation, anything, I hope it's that point right there. And we'll talk a little bit more specifically as to what that means in a second. But some other stuff we'll talk about real quick are how does the web work? What is kind of going on behind the scenes? What is HTTP? And what does it mean to be on client side versus server side, which is probably something that you've heard before. People talk about client side, server side. That's a really important distinction to know when it comes to web dev stuff. And then kind of like, non-exhaustive overview of kind of where things are at with modern web development these days. And if we have time, we'll do a little live demo of some things that we talked about in this little presentation here. So that's kind of my goal right here. I know these slides are beautiful. Shout out Canva for making it look like I'm a saucy designer, but I am not. It's probably the most beautiful presentation that you'll ever see. But yeah, unless my CMO, a good homie Naomi, made the presentation. Otherwise, y'all stuck with what I got. Cool. So drop a thumbs up if you're ready to go. We're going to just kind of jump right into this stuff. All right. I see some thumbs. We in there. Let's do it. All right, cool. So what is the difference between the web and the internet? All right, this is, as much as I'm like live and whatever, I'm saying, this is an open conversation right here. So, people sometimes think about this, and I want y'all to take a second and really think about this. Maybe in the chat, if you want to take a stab at kind of writing the difference between the web and the internet, please feel free. But for a second, I want y'all to really stop and think about this. For some of y'all, you might see this question, you'd be like, yeah, I understand this question. There's a big difference between the web and the internet. You might even be able to articulate that. But for some of us, this question might stump you for a second. It might make you think like, wait a second, a difference? What you mean a difference? The web, the internet, aren't those things kind of the same thing? And like, no shame, I'll put my hand up. Like, how many of us didn't really think there's a big difference between those two things, right? Like, I can honestly say, prior to my journey in web dev, I didn't really know. Like we used to use the word web and internet interchangeably. You know what I'm saying? Like, oh, I'm surfing the web, but it's like, technically it's like, am I surfing the web? Am I on the internet? Or like, I used to think that those things were at least closer in what they meant than really the reality, right? And so the real kind of big point of this whole presentation, like I mentioned earlier, is to say that, you know, there's a difference between these things, right? The internet itself is a infrastructure thing, right? It's a big thing. It's a big deal. The internet is a really big deal, right? It's the best way to think about the internet is it is a network of networks, right? And that's like some Matrix level, Inception level, you know what I mean? My man Leonardo DiCaprio level, like cerebral stuff right there. You know what I'm saying? Like, so when you talk about a network, right? A network is essentially just a series of what we would call nodes that are connected via some type of communication protocol. So if you think about it, like in order to be in a network, me, somebody else, and somebody else have to be connected in some format, and we have to have some protocol for communicating. I have to be able to reach out to person B has to be able to reach out to person C. If person C can reach back out to either of us, then technically you could say we are in a network, right? In the technical sense of the word, not necessarily in the social sense, right? In a technical sense, we call the people that are those little, you know, ABC nodes. The nodes are, in this case, in a technical sense, computers, right? Computer A to computer B to computer C. For computers to be in a network, like I mentioned, they have to have some type of protocol to communicate. And there's a number of ways that computers can be connected to communicate, right? The thing about the internet that is really like what makes it such a crazy invention and such a remarkable tool, and so something that's like so hard to kind of fathom until you really get into like network engineering or anything of that nature, where you're like really like at that machine level, like seeing it in real time. The internet is a network of networks. So right now I'm on my, you know, my Spectrum Wi-Fi, which is like, you know, Spectrum is the one of the biggest internet providers here in New York. And they allow me to connect to a local area network, a LAN network. That is my current Wi-Fi setup, right? So I log in to my router and I'm able to connect my devices. And on my internet network here in my house, I have the ability to see what devices are connected to my internet right now, right? My laptop, my phone, little Apple Watch, you know what I'm saying? If I was like one of those IoT people, you know, my little Bluetooth Wi-Fi toaster, but I ain't balling like that. So, you know what I'm saying? Like the local area kind of has those devices tied to it, right? But y'all are tuning into this presentation. If you're following live right now, you're tuning into this presentation, or even after, you're tuning into this presentation using your own local network, right? Your own Wi-Fi network. But for some reason, my computer is connected to my network and is able to communicate data that's coming down to your computer. For those of y'all on the live right now, it's happening in real time. For those of y'all who watch this later, it's happening in retrospect, right? Or via some other computers in the middle, right? That is all made possible because of the tool of the internet, right? Computer A is able to talk to computer B within its local network, but then beyond that, my network is now being able to connect to your network via some type of a communications bridge, or what we would call a protocol that's allowing our devices or our internet networks to communicate. So the internet is a network of networks. Network, again, set of nodes that are connected via some type of protocol. So when we talk about a network of networks, we're saying that the communication is connecting not only just an individual computer, but a whole network, whether it's your wireless network, your Wi-Fi network, whether it's your Ethernet connection to your internet service provider, whatever the situation is, the internet is connecting all those different networks across the world. And that is kind of ridiculous. It's kind of a big deal. You know what I'm saying? Let's give it up for the people who made the internet, because that's some real like wonder of the world type invention there. The protocol that the internet uses to connect other networks and communicate is called TCP over IP. It's a standardized protocol that the internet uses to connect different devices or different networks, computer networks. And using that protocol, that internet protocol, there's a number of different ways that computer networks can send data to other computers within the network, right? And some of those are FTP, SSH, HTTP, which are different protocols that computers within a network can utilize to connect and share data across the board. So if this is making sense to you, would just love to see you kind of drop a thumb in the chat, or drop a thumb up in the React if that piece of network of networks is making sense. Dope. All right, cool. Appreciate that. Thank y'all. Dope. So big point to make about the internet is it's been around for a while. You know what I'm saying? Like the internet, you probably can't remember a time before the internet. I'm pretty sure it was like the 60s that the internet came out. I'm gonna like quick Google that. You know what I'm saying? I'm gonna fact check myself right here so I ain't spreading fake news on YouTube. You know what I'm saying? When was the internet created? Let's see. Well, if somebody finds it, you want to drop it into the chat. Oh yeah, 1960s. DARPA, you know what I'm saying? Department of Defense. It's kind of crazy how, this is not trying to get political, but, the Department of Defense is responsible for a big portion of the US economy and the budget. So the fact that they spent money on this invention tells you just how important it was at the time to create this system of connecting resources. So they spent a lot of effort in the first creation of an intranet that became the bigger concept for the creation of what we now know as the internet. So unless you was born in the early 50s or 60s, you know what I'm saying? Like you probably don't remember a time before the internet. It's an OG. We are its kids, as Nicki Minaj would say. You know what I'm saying? I bet. So, all right, boom. So we talk about the internet. So now let's talk about the World Wide Web, right? And the World Wide Web, also known as WWW, also known as the web, you know what I'm saying, is one specific method for transmitting and receiving data over the internet. That wasn't a Kendrick level bar. That one was like a little sophisticated. Like that one was like a lot of like words and stuff. So that one was like a, who would I say? That was almost like a Jay Electronica type bar. You know what I'm saying? Like you got to sit back and think about that one for a second. This is one specific method for transmitting and receiving data over the internet. So we just talked about the internet being connecting different networks, right? And because of that connection, computers are now able to connect and send data to other computers over the internet, right? Like I mentioned, there's a number of ways that computers can do that. SSH, FTP, mail servers, etc. But the WWW, the World Wide Web, is one way that computers a standardized way for computers to transmit and receive data over the internet. The World Wide Web was a project, like an academic project that was started by this dude. He lit because he's knighted, you know what I'm saying? Like, dang, his name is Sir Tim Berners-Lee. Like, you gotta put the sir in it because, like, my man was on the knee and the queen like hitting him with the swords and stuff. You know what I'm saying? That's some other level like recognition. But this dude is responsible for starting this academic project that turned into the idea of the World Wide Web. And the reason why was because he was like y'all. He was, in academic setting. And at the time, he was like, what is not lit? Being able to share resources across departments and from research organization to research organization, right? The process of like getting all this information in a consolidated format is not easy. And because of that, there might be some room for innovation in the process of developing a system for us to communicate data over the internet. The internet's doing this great job of connecting all these networks, but if we're only sending data in this format that's built for the terminal, we're kind of missing out on a lot of the possibilities of how we can identify and share and resource or share and identify resources over the internet from computer to computer. So that's one of the things that the World Wide Web project was started to solve. And Sir Tim Berners-Lee created this whole project around this idea of making resources from computer to computer identifiable by what's called a uniform resource locator, which is a URL. how many of y'all have heard the word URL before? You know what I'm saying? You could drop a thumb or you can, you know what I'm saying, do your thing. But how many of y'all knew that that's what it stood for? It was like Uniform Resource Locator. And that's referring to like, yeah, where on this computer is that resource? That's exactly what a URL is. And the whole idea of the web was, what if we can share those uniform resource locators for other computers to access resources, no matter where they're accessing them from? And in order to do that, they had to also create another type of protocol to send that data in a format that would make it easier for computers to identify. And that's where the hypertext transfer protocol comes up. And we see it, and that's HTTP. So when people ask you this question, and people are going to ask you this question, as soon as you say you want to be a web developer, you got to be prepared to answer this question. What is the difference between the web and the internet? Or sometimes people like to ask, like, how does the web work? Which we'll talk a little bit more about in a second. Or like, what is, things like that are questions that people are going to ask, so that you can say that you have an understanding of the fact that those two things are very distinct and very important and in different places. If you care a lot about the, intricacies of the internet, a career in like network engineering, systems engineering, stuff like that would be really up your alley. If you care a lot about the web and you're like, I'm really fascinated by how the web works and like, sending and receiving data over using the web and the, HTTP, web dev and like full stack dev is where you will probably spend a lot of time, because we are the ones that, for the most part, use those protocols for the applications that we're creating and the data that we're transferring all across the board. But, whether you become a web developer or not, we are always interacting with the web via APIs, via like links to other things, resources, et cetera, et cetera. So it's very important, I think, no matter what part of the stack you choose to be on as a software engineer, or even if you don't care to be in software, like it's important, I think, to know all of these topics. So pulse check, if you're rocking with me, we still good to go. You could drop a thumb real quick. You know what I'm saying? I just want to gauge. Yeah. Did you have a question? Go ahead.
Yeah, is it possible, if is there like a way we could follow along with the slides, or this is something you can only see in the recording?
In the way, like, you mean like you want to just get a link to them?
Yeah, kind of like, yeah.
Yeah, I can send it to y'all. Yeah, I was gonna send it to y'all after the thing. Is that cool?
Yeah, that's fine.
I bet. Appreciate you being flexible to the situation. Because if I got unshared and do it just gonna be a whole little thing. But lit. I appreciate y'all for that this is making sense. So big point that we want to make here is that the web is not the same as the internet, right? Bang equals, all of us computer science nerds, bang equals means is not, right? Or these are not equal objects. So that's the big point. And if you got this point in your head, you'll see that the difference between the web, like there's a big difference between the web and the internet. Thumb up to you, because that was the big point that I was trying to make. In a second, we might take a look at Sir Tim Berners-Lee's first website, which I think is a really cool thing to just see. It's kind of funny, but yeah, that was the main point I want to make, is that we use the web. In order to work with the web, we had to use this idea of URLs as well as the hypertext transfer protocol. So now that we kind of got that demystified, oops, going the wrong way. Whoops, yep. How does the web work, right? And, it is a very complicated process that goes into multiple levels of depth of steps. And so I'm by no means trying to say that it's just this simple as like 3 steps. I'm just trying to say that at the end of the day, we can kind of think about these big pieces of the system that are important to know. So how does the web work, right? When you go to your browser, right, and you type in google.com, right? What happens next, right? You press enter and then, magic, and then boom, you see the google.com, you see Google's nice little banner ad and like, what I'm saying, whatever the drawing of the day is or whatever, right? But what's going on behind the scenes? That's the important question that someone might ask you. Like, what's going on behind the scenes? And what's really happening is first of all, your computer is already connected to some network. Hopefully, you're connected to the internet. You have to be connected to the internet. Otherwise, none of this is going to even make sense. It's not going to work. So as you're connected to the internet, once you type in the google.com into your browser, right? Your computer is going to make a connection to your internet service provider. Mine is Spectrum. Yours might be Verizon if you bougie like that. You know what I'm saying? Like Comcast if you don't live in New York. You know what I mean? Like all those different internet service providers. AT&T. You know what I mean? Like they have. They are responsible for allowing your computer to connect and allow for this next bit of the process to happen. Which basically, what happens next is that you're typing in google.com, right? We call that a domain, like a domain name, right? And or you could think of a domain name also as like a web address. It's an address that corresponds to a particular site, right? Google.com, GitHub.com, whatever. As soon as you type in that domain, right, your internet service provider, you connect with via your internet service provider to something that's called a DNS server. The DNS stands for the domain name system, and the domain name system is a very important process to transferring basically the domain name that you're typing in to your computer as what's called an IP address. And an IP address is essentially a numerical representation of a particular computer server that is tied to that specific domain. So every website that has a domain that we know, google.com, twitter.com, New York Times, any website that you go to online has a corresponding IP address, which is essentially the like a numerical representation. We use domains as people because it's easier for me to remember google.com than it is for me to remember 142.50.361 or whatever. You know what I'm saying? Like the process though for a computer is the computer needs to know that specific number because it then does a number of processes that allow for us to establish a connection to that other computer, right? And it uses the internet protocols that we were talking about before in order to establish that connection. So the benefit of a computer being on the internet, being in a network, is it has a communication bridge to other computers in the network. The thing about the internet, to bring this all back home, is that the internet allows us to connect from network to network. So no matter what computer you have or what local computer you're on, you can establish connections to other computers across networks. And that's what the internet allows us to do. So the domain name system process, or the DNS process, is the process of getting the IP address so that your computer can make a connection, establish a connection to another computer on a different network. And we call the computer that you're trying to establish a connection to a server, another server, right? Once your computer establishes or sends out a request to establish a connection to that particular server, that other computer that is receiving the request that your computer is making will say, "Oh, cool, Cam's trying to reach this Google server, right?" And they're like, "Okay, is it cool for us to establish a connection?" It's like, "Yeah, it's all good." Little handshake happens. It's really called a handshake happens. And once that handshake happens, my computer, that other computer get connected, and I receive back a response from Google server that sends me back some data. And that data is exactly what I see on the screen, right? In most cases, the data that you get back, from a request to another server, for the most part, is like some of the first bits of data that you get back is HTML like page, right? So that once your computer sees that HTML page, the browser that you're on refreshes with the data from that HTML page, and boom, you see that actual website. So that's the process that's happening. You say, "I want to go to some specific website name." Your computer's like, "I bet, let me look up through this like little phone book like system, domain name system, to figure out what's the corresponding IP address." The DNS process is very is very robust. And it's something that if you really dive deep into it, there's a lot more layers of complexities as to how your computer actually gets that IP address. So I encourage you to read more about it if you're interested. But, you know, for the sake of clarity, imagine it's like your computer's looking through a Rolodex of stuff it knows and maybe hitting up a couple people that might know. And it's like, oh, what's this domain name's IP address? Once it gets it back, however it gets it back, it says, all right, cool. Let's try to make a connection. Once I've tried to make a connection and it says it's successful, then I get back a response to my request from that particular server that I was talking to. So again, I'm gonna pause, check for understanding. Does that make sense? We're gonna see a couple of examples of what I'm talking about in a bit, but if that makes sense, can you just drop a thumb up or react so real quick so I could just make sure we kind of in a good place? Dope. Cool. I bet. So we're talking a lot about this idea of like requests and responses, right? Like I'm making a request and I'm getting back a response. I want y'all to keep those two words in mind, request and response. Those are really important words when it comes to like the web dev stuff. So hopefully I'm going the right way. And exactly into this next kind of part of this whole thing. When we're talking about a request, right? So picture me here, you know what I'm saying? I am definitely a little bit more melanated than this, but picture me here, you know what I'm saying? Type on my computer. I'm making a request to a server. And, you know, sometimes in our imagination, we think about servers in this big kind of warehouse-like setting. But a server can be any other computer that is just on a different network, right? But the process that we're going through is I'm typing, making a request, reach out to a different computer somewhere, and that computer sends me back a response that my computer now receives and can process and do all types of other stuff, right? The process here, especially the process that we're doing when we're talking about on the web, right? On the web of me on my browser typing google.com, right? We're talking about the web process of communication. There are other ways to establish connections to computers on a different network, but we're specifically talking about over the web. And the protocol that we use to establish these requests and responses is called the Hypertext Transfer Protocol, or HTTP. Just show of hands or show of thumbs, you know what I'm saying? How many of y'all have heard of HTTP before? Dope. Yeah, I'm seeing some stuff. Yeah, right. Like HTTP, right? Like if you think about it, most times, like, you know, you see this on like the browser window when you're typing in a specific domain. It says like HTTPS or HTTP, blah, 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 whatever the website is you're going to, right? What that is really saying is you're using that hypertext transfer protocol via your browser to establish a request. You're sending a request to that particular server that you're looking for, and that server is going to send back a response to your computer. Again, requests are just like data that your computer sends over to the corresponding server, and it says something like, hey, here's what I'm trying to do with the data that you're going to give me back. And that other server can say, cool, I see what you're trying to request, and here's the data. Here's a data object back as a response. So servers can either accept and, you know, everything go well and say, yeah, everything good, and it processes things well, or it can say, hey, you know, I actually don't approve this request because you're not authenticated, right? If I was trying to reach out to a Twitter server right now and pull all of the information I can about all the users on Twitter, I can't do that specifically just with a request from my local computer, but I could do that if I authenticate with Twitter and, you know, use their API or something like that, which would allow me some of that data to come back. So requests and responses are the process of trying to get and receive data from computer to computer via the web. And so the HTTP protocol is the protocol of communication that we use to send that data between computer to computer over the web. Cool. So last point here that I want to make is that we call the computer that is making a request a client. And we call the computer that is responding to a request a server. So you hear about servers all the time, but really all a server is just a computer that's been set up to receive requests from another computer and then send a response back, send some type of data back. Any computer can be a client so long as you're reaching out to the server. It's more about the position you are in a relationship than it is about a specific type of computer. Although, you know, the reason why computer servers are normally stored like this in these weird warehouses, stuff like that, is because they don't really want these computers to be damaged in any way or like, you know, doing too much, because you want these computers to be on all the time to process a request that's coming in. You wouldn't want a bad server would be a server that you'd have to like wake up every time somebody was trying to request information, right? Then you'd be sitting there waiting for your response, versus a good server is like, you know, got the response, sent it back, you know, got the request, sent it back the response. Any client could be a server. You could turn your local computer to a server, which is something that we'll talk a lot about when we start working with React and creating a local server to launch our code. And we'll talk about some of the benefits of that probably next week. But these are the different definitions that you'll hear about, like clients and servers. So we actually call this whole process, outside of like the kind of HTTP lens, we call this the client server model. And the client server model is like one of those big things that people will expect you to kind of know about. But when they're talking about the client server model, if they're like on a web dev interview, like, hey, can you tell me about what is the client server model? All you got to be able to talk about is clients are specific computers that make requests to other servers, which are different computers, and those servers send back a response to the client. And there's like a process of the client establishing a connection to the server and the server sending back information to the client. Groovy, we good on this? If you could just throw a thumb up, and I'll keep it pushing. Cool. Thank y'all. Appreciate that. All right. Dope. So when clients are sending requests to servers, they have to send, like I mentioned, they send some data to the server to say, hey, you know, here's what I'm trying to do. That process is what we call a HTTP method. So they send a data object in the form of this HTTP method that says, hey, I'm trying to get data from your server, or hey, I'm trying to post data to your server, or I'm trying to put data in the server, or trying to delete data, right? So every time you make a request online, you're sending one of these methods to a corresponding server. The most common method that we use is the get method. Or sometimes, you know, we say request, like the get request, right? You're saying, oh, I'm making a get request to that server. The get request is exactly what happens when you type google.com and press enter on your browser. You're sending a get method request to the Google server, and that's saying, hey, I'm just trying to read data from this particular domain name. And 9 times out of 10, I wouldn't say 9 times out of 10. That's cap. I'm not trying to cap right now. Why am I capping like 9 times out of 10? Most times when you make a get request on the web, you're going to get back some data. The most common format that you get data back in the get request is like JSON or like HTML, right? For the most part. HTML is the language that we'll talk about in a second, but HTML is what we see when we kind of actually want to talk about a web page, right? So what happens when you go to google.com and you say get request to Google, you're going to get data back from the server and in the format of HTML. Post requests are about inserting data. Like I said, puts and patched requests are about updating data. Not really as used as much as post, get, and post. And then delete is about deleting data. The two most important ones for every web developer to know definitely are the get and post requests. We use these two requests pretty often. Put, patch, and delete are circumstantial based on different things you're doing on your server. So this is the request side, right? And like requests always send this method to this corresponding server. But then we also have on the response side, right? Some data that comes back in responses, depending on what you're requesting, you might get actual data. So like you might get like your HTML, you might get your JSON, you might get like whatever. But on the response side, you always get a status code, which is essentially it's a 3-digit code that reflects whether or not your request was successful or what happened in the response. So 200 level requests, so 200, 201, 202, whatever, anything that starts with a 2 is a successful request. Anything that starts with a 3 is a redirect. So imagine you go on a site and like they recently changed their server, so they no longer use a specific name, or they change something about their server. Sometimes what they do is redirect you, right? It happens a lot when a company gets bought out or something, right? Like you go to that old website and it takes you to the new website real quick. That process of the browser saying, oh, actually we're going here, is called a redirect. And you'll see a redirect reflected in a 300 level response in HTTP. 400 level responses are client errors, right? So the most infamous one is 404. So imagine you like going onto a server, you're trying to find a resource and you say, you type the wrong name or something and you get that, oh, we can't find this page, right? That's normally a 404 level error, which means that the client, so you or whoever made that request, is put an error in their request that we can't process. The server's like, we don't know what you're talking about here. 500 level requests or response statuses are server errors. So this is on the other side, like you did everything right, but the server messing up. So whenever you get back a 500 level error, it means that the server, something's wrong with the server. And you know, it's rare that you say that things are happening on 500 levels unless there's like really big problems happening with servers. If you go on Google and you get a 500 level error, that's when we would say Google is down. You know what I'm saying? Or Netflix is down. You know what I'm saying? Y'all know we'd be like, we'd be like panicking about like Netflix is down, Google is down, like Dropbox is down. You know what I'm saying? Like that's because those servers are now sending us back a 500 level response, which means we can't really see anything. We're not getting back any resources or anything. The page might not even be loading the right way. That's reflected in the status codes that we're seeing on the servers. So yeah, these are the response side, and we just talked about the request side. Both methods, like the methods we use and the status codes that we get back, are important to know about, just because when you start actually sending data from computer to computer via the web, you look at all of these things to one, make the right request, or two, make sure that the request was successful. Cool. So we only got a couple more drawings here. So now that we've talked a lot about like this request response and client server model, the important thing to kind of let's just take a step out for a second and just refresh our minds on this, right? Client side refers to anything on a web application that take place on the end user's computer. So if you're the one making the request, you're the client. So anything that we talk about client side is happening on your computer. Server side is anything that's happening on the server's computer. So the one receiving the request and responding to the request. So that computer that is receiving and responding is the server, right? So client side and server side also is where the distinction gets made between what we call front-end development and back-end development too. There's a lot that you could do on client side and server side, you know what I'm saying? But when we start talking about front-end development, we're talking about programming that affects what the client is going to see. So the person that's going to eventually make a request and try to get some data back from a server, right? And the server side corresponds more to what we call back-end development, which corresponds to the programming that you don't see as a client. It's the stuff that happens on the back end and then comes back to you in the format of a response. So, you know, you're processing some like important thing, and you like on the client side, you press a button, you like type your name and press enter, right? And you're trying to log in. Well, the login process doesn't actually normally take place on the client side because it's a better process on the server. It's more secure that way. So on the server side, you know, it might receive a request from a client that's trying to log in. does all the data processing of verifying, are you in this database with this right password, blah, 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 blah. And then it says, okay, yeah, that person's back. And it sends back some data as a response to validate your authentication. And that's kind of an example of how this whole client side, server side interaction happens and takes place. But I really want y'all to get in your head that this is also where that line of like front end development versus back end development comes in. And so, you know, you got to kind of understand that both of those things are important if you want to be what we call a full stack web developer. Right. So this is where all this comes back. Y'all's probably like, dang, Cam out here rambling. Like, you know what I'm saying? I'm trying to put y'all on game. You know what I'm saying? Like, when you say that you want to be a full stack developer, you're saying that you want to do work in the front end and on the back end. And so it's just important to know that what you're signing up for with front end development is all of the stuff that happens on the client side. And on the back end, you're saying you are signing up for all the stuff that happens on the server side. Does that make sense? Just want to kind of get a pulse check on that point. Dope. Okay, seeing some thumbs. Appreciate y'all. Cool. So, you know, so now that we're talking about like full stack stuff, right? And, you know, y'all are here for the most part. Most of the folks that are tuning in live right now are here because they want to be full stack web devs, right? And that's why you probably took the class, or that's why you kind of, you know, sign up to talk to your boy Cam and hear about all this stuff that I be doing, because I love being a full stack developer, right? But like I said, it comes with a lot of responsibility because you got to know stuff on the front end and you got to know stuff on the back end. On the front end side, we leverage HTML and CSS is like the main stuff you need to know when it comes to like front end, like what happens with regards to the creation of the website that you actually see, right? The UI, I guess, if you want to put it in design terms, right? HTML stands for the hypertext markup language, and it's the standard language that we use to structure a particular website. CSS are cascading style sheets that define the rules that describe the style of an HTML document. So that's where all the, you know, pizzazz comes from. Also important to know for the web, especially on the front end, is a language like JavaScript or even like one like PHP, which are used for processing things on the client side in terms of like actions that are taking place on a website. We use JavaScript, we use PHP a lot. But there's a number of different languages you can use also when it comes to working with the web, because like I mentioned, there's the front end and there's the back end, right? So most of y'all who are probably tuning in know some Java or, you know, some Python, and both of those languages are great back end languages to know. You can use those languages to create your own servers, to do a bunch of data processing, you know, financial institutions like using Java, you know, not databases, but like organizations that do a lot of data analysis and stuff like that leverage Python a lot in their backends, right? So you can make choices on what language you use based on what kind of a architecture you're building, right? But at the end of the day, when you're talking about the front end, you're normally connecting JavaScript, HTML, CSS, or if you're like, you know, maybe building WordPress or something older, or, you know, PHP, which is still a viable language these days, but a lot of folks are now using JavaScript more on the front end as their programming language of choice. There's a number of different like front end and back end frameworks too. So outside of just the languages that you need to know as a web dev, or like HTML and CSS, you just got to learn a bunch of different frameworks as well to like kind of master your craft and kind of master your part of the stack that you work well in, right? On the front end, there's frameworks like Angular, React, and Vue. We're going to be talking a lot about React in the next few weeks. And if you kind of stalk this page, I talk a lot about React. But on the backend side, you know, Node.js is a JavaScript-based backend framework. Django is a Python-based backend framework. There's also Flask. There's also I'm blanking on this, John, from Java. It'll come back to me. Yeah, Spring. Thank you. See, that's why I love y'all. You know what I'm saying? That's why I rock with y'all. Spring API that you could use in like Spring Boot, which you use in Java to create like backend servers in Java, right? So all those different languages have the ability to create servers, and it's up to you to figure out, based on what you're building, what makes the most sense. Also based on like what team you're working with, what makes the most sense. Sometimes a lot of stuff can get really arbitrary, but also there are very real like efficiency things you can choose between, you know, setting up your website and your web application in one way or another way. And that is where, like, you know, your seniority in the web dev space comes. It's like building more stuff so you get used to using other tools and you can make decisions based on what tools you know for what makes sense for the project that you're working on. And that's where the fun comes in. You're always learning as a full stack developer. Because as you just heard, the web is a very complicated thing, and working with it is there's no shortage of things to learn. There's like so much there, and I think that is a very viable space to be trying to find work nowadays, because it connects a lot of the dots. Whether you are someone inclined with design and you want to be on the front end, whether you want to be on the back end doing more server stuff and doing bigger kind of like algorithmic programming and things like that. That's where all the stuff that you're probably learning, if you're like learning a code at school, or if you're like learning a code and you chose a language like Java to start with, that's where you would apply all of that stuff that you're probably talking about. Unless you're doing like game development, which, you know, game development is lit in its own field of itself, which is pretty dope too. But yeah, full stack and being on the web is real cool because it allows you to work with a number of different languages, frameworks, and the OG of like web stuff, which is HTML and CSS. So yeah, this is my little presentation on the web dev side, and like, you know, what does it mean when we talk about the web and web development? And yeah, I'm open to questions if y'all got any questions on the whole presentation. Otherwise, if you don't, drop a thumb up so I know that we was rocking, you know what I'm saying? Like, y'all really sat through that drawing. Like, appreciate y'all. Go ahead, Brianna.
I just wanted to know what's your opinion on Angular, because I keep hearing about Angular for front-end development, and I'm mainly familiar with React and Vue. I've never used Angular before, but a lot of people are saying that Angular is basically not as good as React, so I just wanted to get your opinion.
Yeah, I think web devs are really like picky with what framework they like and what framework they don't like. I mean, at the end of the day, both Angular and React are frameworks that are designed to use JavaScript to make your process of creating sites better, right? So Angular also, a lot of folks like Angular if they're like working with TypeScript, which is kind of like a newer extension of like JavaScript, the JavaScript language, to like kind of work on creating more standardized types. And if you're familiar with Java, you use types when you create variables, but in JavaScript, you don't necessarily need to do that. But TypeScript makes that the case. So some folks that like using TypeScript say that Angular is better in that sense. But honestly, it really, I would say like, it really kind of matters more once you start thinking about optimizing your efficiency and stuff in the code. Like, because at the end of the day, you know, on the client side, people aren't even looking at the code that you wrote. They're just looking at, does this website show up, and can I do what I came here to do? You know what I mean? So that's more of an engineering preference than it is a preference that changes anything in real life for your client outside of maybe speed and optimization of the page. Does that make sense?
Yeah, thank you.
Yeah, no problem. Any other questions from the people?
Yeah, can you just explain what a framework is one more time?
So yeah, a framework is like essentially it's code that was written in a particular programming language that then then gives you like more of a set of tools that you can use to build your code easier. So it's like certain languages call things frameworks or libraries or packages even, but they're basically like tool chains that exist to like make your workflow easier than just using the regular language all in of itself. So when we say like a JavaScript framework, it's a framework that's written in JavaScript to be used by JavaScript developers. And that when we're talking about like a JavaScript framework, right? But in Python, we don't really call things frameworks as much in Python. We call them libraries. But the concept is the same. It's like somebody created something to let you work with that language a little bit easier. Make sense?
Yeah, I think so. So it'd be like importing in Java or like in C++, I know you hashtag insert, right? Something like that, right? Like those
So yeah,
libraries.
so like in JavaScript, we have things called packages that you would import and stuff like that. But a framework is more like a like engineering level, like is like a thing to improve your engineering process across the board. So it's like not necessarily like a thing you'd put in just your code, but it's like the way you set up your your project would be using this framework to like pull all the right files and connect the dots in those files the right way so that it becomes easier for you to build on top of. Does that make sense?
Yeah, I think so. So just to clarify, just like make sure
Mhm.
that I got it.
Yeah.
It's like a set of tools I can use to build
Mhm.
whatever I'm trying to build in essence, right?
Right. Yeah. So like
All right,
with
great. Then I
React,
got it.
yeah. So like with React, for instance, like you could build everything that you do with React in just regular JavaScript, but React provides a framework that allows you to start your project off in a specific way that should improve your development process as an engineer.
All right, thanks. Got it.
No, it's nice, nice question. Any other questions? Word. All
Professor,
right, go ahead.
quick question. We're gonna
Mhm.
learn React.js now. What is the difference between React and React Native?
Oh yeah, great question. So React and React Native, React is meant for the web, React Native is meant for mobile. But React Native uses the React framework it is an extension of the React framework. So if you know React, learning React Native is pretty simple. But it's just you use React Native when you're building mobile applications versus React, which is used for the web.
But it's very similar, right?
Yeah.
Oh, okay, cool.
User. Cool. Any other questions? If you're cool, just give me a thumbs up one more time so I know we good on this piece. All right, I'm seeing a whole lot of thumbs. You know what I'm saying? If you enjoyed this little presentation, you're gonna show some love to your boy in the chat. You know what I'm saying? I'm out here, you know what I mean? Just trying to break down tech concepts for the people, you know what I'm saying? Like really be out here. But cool. I hope that y'all understand these concepts. So what I'd like to do real quick is take a quick break. And then we'll get at some of the live demo stuff that I talked about, since for some reason I talked with enough time left over to to do that. So let's take 5, and then we'll be right back on here real quick. I'm gonna stop the